Hello everyone and welcome to 30 days of DSA challenge, where we will be solving a DSA problem every day for the next 30 days. So this is our day number 11, where we will solve a problem based on Q, and the level of this question is going to be easy. The name of this question is implement Q using stacks. You will get this question link in description, and you can also download this Excel sheet from description. Now without wasting much time, let's see our question on LeetCode. So this is our question on LeetCode. It says to implement a first in first out, also known as FIFO, queue using only 2 stacks. So the question is saying to implement a queue, right, which works on the property of FIFO, that is first in first out, by using 2 stacks. So in a way you can say the question is giving you a hint that we can use 2 stacks. How to use 2 stacks, we will look into it later, but firstly let's read the question. So the implemented queue should support all the functions of a normal queue. Those are push, peek, pop and empty, right? Now implement the myQueue class. So we have one class named as myQueue and we have to implement it. So we have different functions. The very first one is void push int x. So it basically pushes element x to the back of the queue. Then we have int pop. It removes the element from the front of the queue and returns it, right? So this pop functions, it removes the element from the front of the queue and returns it, right? Then we have int peek. So it returns the element at the front of the queue. Then we have boolean empty. It returns true if the queue is empty or false otherwise. Okay, you must use only standard operations of a stack, which means only push to top, peek, pop from top, size and is empty operations are valid. So questions is just basically saying that we just have to use the standard operations of stack, whatever the standard operations we have in stack data structure. Now depending upon your language, the stack may not be supported natively. You may simulate a stack using a list or DQ, that is double-ended queue, as long as you use only a stack's standard operation. So basically question says that if your programming language does not support stack data structure, then you can implement, right? Then you can implement stack data structure either by using list or by using DQ, right? And here we have one example test case, and here are some constraints. At most 100 calls will be made for push, pop, peek and empty, and all the call to pop and peek are valid, right? So this line is very important, that all the calls to pop and peek are valid, right? So basically let's say if we don't have any element into our queue and we are still calling this pop method or pop function, then it should give us error, right? But the question says that all the calls for pop are valid, means if our queue is empty, then this pop method will never get called, right? And similarly, if our queue is empty, then this peek function will also never be called. So we do not have to think about that particular scenario, right? We do not have to think about underflow case, right? I hope it is clear. Now let's analyze this problem and let's think about how we are going to solve it by taking some examples. Okay, so firstly let me just explain you how stack and queue data structure works. So we know that stack works on the principle of last in first out, and queue works on the principle of first in first out, right? Now let's say we have different operations. So the first operation is push 10, then we will push 10 into our stack and we will push 10 into our queue as well. Then the next operation is push 12, then we will push 12 into our stack and we will push 12 into our queue as well. And let's say we have one more operation, that is push 50, then we will push 50 into our stack and we will push 50 into our queue as well, right? Now the difference comes, right? Now let's say question says to pop, right? Question says to pop. Now we know that stack works on last in first out, right? Last in first out. So the element which was entered into our stack at the end will be removed first, right? So when this pop operation will be encountered, then this 50 will be taken out from our stack, right? 50 will be taken out from our stack. But here in the case of queue, it works on the principle of first in, first out. So the element which was entered into our queue first, right? The element which was entered into our queue first will be removed first. So when we encounter this pop operation, then queue will remove this 10, right? Queue will remove this 10. So this was a basic difference between stack and queue, and we also have some more differences, such as let's say if we need to find the top element which is present into our stack, then it will be nothing but the 12, right? But in queue we do not have specifically when we talk about C++, then in queue we do not have any operation or a function known as top. Here we have a function known as front, right? Front. So this is a built-in function for queue. It basically gives us the first element, right? It gives us the first element which is into our queue. So when we do this front operation, then we will get this 12, right? We will get this 12 because it is in the front, right? If you see from this particular side, I'm sorry, this diagram is worst. Okay, so for example, if you see from this side, then this 12 is the first element, right? This 12 is the first element. So when we do front, then we get the element which is at the front, into our queue. And when we do top operation, then we get the element which is present at the top, or you can say that the element which is present at the back of the queue. So this is a basic difference. Now let's think of how we are going to implement queue. How we are going to implement queue using stack. Okay. So let me just create some stack. Okay. So in the question it was mentioned that we have to solve this problem using two stacks, right? Using two stacks, right? And when we talk about stacks, then we have to use the standard operations, and the standard operations are push, pop, top, and is empty, right? These are the standard operations which we have when we talk about stack. So let's say this is our stack number 1, this is our stack number 2, right? This is stack 1, this is stack 2. Okay, now let's say we are getting different operations, and our first operation is to push 12 into our stack, right? So we will push this 12 into our stack number 1, right? That is S1. So we pushed 12 here. Then we have next operation which says to push 15 into our stack. Then we will push 15 here. Now the next operation is it says to push 20 into our stack. Then we pushed 20 here, right? And we also know that the top will be pointing at 20, right? Top will be pointing at 20. Now let's say the next operation is a pop operation, right? Let's say the next operation is a pop operation. So we know that if I apply pop operation on any simple stack, then it will pop out the element which is present at the top, which is this 20, right? Which is this 20. But we have to implement queue here, right? We have to implement queue here, and queue works on the principle of first in, first out. So the element which was entered into our stack at first, it should be removed, right? It should be removed. So the element which was entered into our stack first is nothing but 12, right? So we have to remove this 12 when we are getting the pop operation, right? Now how to do this? Because if I directly do a pop operation into my stack, then it will remove the element which is present at the top, which is 20. But it is wrong, because here we are implementing stack, right? Here we are implementing queue, here we are implementing queue. So how to do this? So in the question it was mentioned, right? It was like a hint that we can use probably two stacks. So this is stack 1 and this is stack 2. Now what if I put all these elements into my stack 2? How it will look? Let's think of it. So what's the first element present into our stack S1? It is 20. So I will put this 20 into my stack 2 and I will remove it, right? And I will remove it. Now what's the first element? What is the topmost element present into our stack right now? It is nothing but 15, right? So I will put it into my stack number 2 and I will remove it from stack number 1. Okay, now again, what is the topmost element present in stack number S1? Stack number S1, it is nothing but 12. So I will remove this 12 and I will put it into my stack number 2 and I will remove it from here. I will remove it from here, right? Now in stack number 2, in stack number 2, my top pointer, right? My top will be pointing here, right? Top will be pointing here. And now if I do a pop operation, then this 12 will be removed, right? Then this 12 will be removed, and this is indeed the functionality of queue, that is first in first out. Because if you see clearly, then this 12 was the first element which we had entered into our queue, and we are deleting this only. So in this way we can probably do the pop operation. So what we have done till here is, whenever we are getting a push operation, what we are doing, we are just simply pushing our element, right? We are just simply pushing our value, or you can say the element, in stack number 1, right? In stack number 1. Now whenever we have a pop operation, then what we are doing, we are just shifting all the elements from S1, that is from stack number 1 to stack number 2, and then we are doing a pop operation. On S2, right? So this is something what we have to do, right? Now let's come back to the same question, right? Okay, now let's say the next operation is to push 15 here, right? So we already have 15, let's say is to push 21 here. Then what we will do, it is a push operation, so we will simply push it into our stack number 1, that is S1. So I will push 21 here, right? Now let's say the next operation is to again push 30, so I will push 30 into my S1. Now again my next operation is a pop operation. Then what I will do, I will simply pop out the element from S2, right? S2, right? The top is pointing to 15, and this will indeed be the first element present into my queue, because after deleting this 12, right? The next element, right? The next element which had entered into our queue first was this 15, right? So I can just simply delete this. right? I can just simply delete this. Now again, let's say we have another pop operation. What we will do, we will remove the topmost element from S2. So we will do this, right? Now let's say we again have a pop operation. Then what we will do, because here in S2 we have nothing to pop out. Then what we will do, then we will again push all the elements from S1 to S2, right? Then we will again put all the elements from stack number S1 to stack S2. So the top is currently pointing at 30 in stack number S1, so we'll push it into S2. So 30 will come here and this 30 will get deleted, right? Now we have 21, so it will again get deleted from S1 and it will come to S2, right? Now we can do this pop operation, right? Because our top will be pointing to 21, and now we can normally do the pop operation. So what we learned from this particular example is that if our S2, right, if our S2 is empty, right, if S2 is empty, then we have to put all the elements from S1 to S2, and then we have to do a pop operation, right? Else, if our S2 is not empty, then we can directly do a pop operation, right? Now let me just take this same example, and now let's think of how we are going to implement the peak function, right? So before that, if needed, I will also explain you what is the meaning of peak and what it is doing here. So let's say the first operation is to push 12. So I will just simply push it into my stack S1. Let's say the next operation is to push 21. I will push it into my S1. Now let's say the next operation is to push 5. I will push 5 into my S1. Now let's say the next operation is nothing but peak. So what is this peak? And how it works? So here I explained you, and here also I told you that we have a function known as front in queue. What it does, it gives us the first element present into our queue, right? Or you can say it gives us the first element which was entered into our queue, right? First element which was entered into our queue. So here with this peak function, we are implementing the same front function, right? We are implementing the same functionality. Okay, now let's say if the next operation is a peak operation, what does this peak operation will do? It will return us the first element which was entered into our queue, right? First element. Now what is the first element? It is nothing but the 12. Now how I will return this 12? Because if I try to do a top operation, then it will return me 5, but this is wrong. Then again what we can do, again we can take help of our stack number 2, that is S2. What we will do, again we will put all the elements into our S2 and we will remove it from S1. So right, what is the topmost element? It is 5, so I will put it in S2 and I will remove it from here. Then what's the second topmost? It is 21. I will put it into S2 and I will remove it from here. Then what is the topmost element? It is 12. So I will put it into S2 and then I will remove it from here. Right now our top of the S2, right? Top of the stack number 2 or S2 will be pointing at 12, right? Will be pointing at 12. And what does this peak returns? It returns the first element which was entered into our queue, and the first element entered into our queue was indeed 12. Then I can just directly return this 12. From this top functionality of stack, right? So I hope this particular thing is also clear. Clear. Now let's say we have more operations such as push 55. Then we will push 55 into our stack. Then we have next operations such as push 20. Then I will push 20 in here. And let's say next operation is to again a peak operation. Then what I will do, I just do not need to do anything. I will see that this S2 is empty or not. You can directly see that it is not empty. Okay, if it is not empty, then return the topmost element. And it will be indeed my correct answer for this peak functionality, right? So I hope this particular thing is also clear. So when we are implementing this peak, right? Then also we have to do the same thing, right? Firstly, we have to check, right? If my S2 is empty, right? If the S2 is empty, then what we will do, we will put all the elements from S1 to S2 and then we will return S2.top, right? S2.top. If this is not the case, it means we already have some elements in S2. Then I can just directly return S2.top, right? Then I can directly return this S2.top. Okay, this is also done. Now what can be our next operation? So let's say the next operation is empty, right? Is empty. Now how we will implement this functionality? So this is very easy, right? This is very easy. See, we have to return true when the size of our stack is equal to 0, right? And we have to return false when the size of our stack is not equal to 0, right? So this is something what we have to do, correct? Okay, now the next point is how we can calculate the size. So calculating size is very easy, right? Let me just explain it to you here, right? So let's say this is my queue, right? And I did a push operation of 12, right? So I will push 12 here. Now what will happen? What is the size of my queue? Let me just write it again. Q. Okay. So when I push 12 into my queue, what is the size? Size is nothing but 1, right? When I will push 13 here, then 13 will be added into my queue, and now my size will become +1, it will become 2, right? Again, if I do a push operation of 14, then this 14 will be entered into my queue, and the size will again increment by 1, so the size will become 3, correct? Now let's say we are doing a pop operation, so the first element which was entered into our queue was 12, so it will be removed, so when we are doing a pop operation, we removed one element, so now my size will decrement by 1, and now the size of the queue will become equal to 2, right? You can see that we have 2 elements. Now let's say the next operation is again to push 20, then I will push 20 here, it is a push operation, then my size will be incremented by 1, right? My size will be incremented by 1, so right now the size is 2, so 2 plus 1 is equal to 3. Again, if I got a pop operation, I will remove this 13, and my size will decrement by 1, and my size will become 2, correct? So this size is very easy. We can getting the size of our queue is very easy. We will just use one variable named as size, and this will be done. And here we will check if the size is equal to 0, we will return true, and if the size is not equal to 0, we will return false, right? So I hope the intuition is clear. This is pretty straightforward. This is very easy. Now let's think of how we are going to code this. So very first, and a very basic functionality or method or function will be push operation, right? So let's say we have this operation void push, and this is the value int 12 which we have to push. Then what we will do, we will simply push it into our stack number 1, right? We will do s1 dot push the val, right? So we have 2 stacks, right? We have 2 stack s1 and s2, and we will also have a variable named as size which will be initially equal to 0, correct? Now whenever I am pushing anything into my queue, then the size of my queue is getting increased, so here I will do size plus, that size is increased by 1, right? Now let's say the next operation is int pop, right? Int pop. So in this pop operation, what we have to do, we have to pop out the first element which is entered into our queue, and we also need to return that element, right? Okay, so how we are going to do that? So firstly, I will check if not of s2 dot empty, right? So here I am just checking if the stack number 2 or s2 is not empty, then what I need to do, right? So I can get the topmost element, right, by using this int element, ele, in the short form int element is equal to s2 dot top, then I can do s2 dot pop, and when I'm doing a pop operation, so my size is decreasing, so I'll do size minus, and I can just simply return this element, right? I can just simply return this ele element, right? So this is for the scenario where s2 is not empty. We have some elements into my s2. So what I did, I basically took the element into one variable named as ele, because I have to return it, right? You can see the return type is int for this function, right? So I have to return it, so I just stored it into ele variable. Then I will pop it out, then I will decrement the size because I am doing a pop operation, so the size of my stack will decrement by 1, and then I am just returning the element. Okay, now if this is not the case, else condition. In else condition, what will happen? Here we can say that my s2 is empty, right? We can say that my s2 is empty. Now if it is empty, what we have to do, we have to put all the elements from stack number 1 in stack number 2, right? So how we will do this? It is again very easy. We will write while not of s1 dot empty, right? While my s1, while my stack number 1 is not empty, what we have to do, you have to do st dot push s1 dot top, correct? And then you have to do s1 dot pop, right? So in this way, all the elements from s1 will be shifted into s2, Now what we have to do, we will do the same thing. We will take the element which is present at the top, so I'll write s2 dot top. Okay, I will take the element which is present at the top. After taking it, I will do s2 dot pop. I will do s2 dot pop. When I'm doing a pop operation, so the size will be decremented by 1, right? And at the end, I will return the element. And this pop method will be completed, right? So this is the scenario when stack number 2 or s2 is non-empty, right? And this is the case when it is empty, right? When our stack s2 is empty. So if my stack s2 is empty, I am just simply putting all the elements from stack number s1 into stack number s2, and then I am getting the topmost element. I am removing it, I am popping out, I am just decrementing the size, and I am returning it, right? So I hope this is also clear. Then the next function is going to be int top, right? Int top. So we have to return the topmost element from our stack. So again, it is going to be similar of our pop operation. First we will check if not of s2 dot empty, right? If my stack number 2 is non-empty, right? If it is non-empty, then what I need, I just need to return the topmost element, right? I just need to return the topmost element. So I can just directly return s2 dot top, right? If it is non-empty, right? Now if it is empty, right, if my s2 is empty, then what I will do, I will again push all the elements from s1 to s2. So the code will be simple, very similar. While s1 not of s1 dot empty, while it is not empty, just push all the elements from s1 to s2. So we can directly write that like this, s2 dot push s1 dot top, then we will do s1 dot pop, right? After doing this, we can directly return the s2 dot top, right? So this is the code for the top operation. And the last but not the least is empty. So it is going to be a boolean function, is empty. So what we will do, we will just simply return size equal to 0, correct? So if the size is equal to 0, then it will return true. Then if the size is equal to 0, then it will return true. Else if our size is not equal to 0, then it will return false. So we can just directly write this by using this method. We can directly write return size double equal to 0, right, with this comparator operator. So I hope this is clear. So this was all about the code. Now let's analyze the time complexity and you can say the space complexity. So basically we are using two stacks, s1 and s2. So you can say that the space complexity is going to be near about O of n, or you can say O of 2n, because we are using two separate stacks, right? Now if we talk about this push operation, then this push operation is taking O of 1 time complexity, right? Because we are just doing s1 dot push and we are doing size plus plus. Now this pop operation, the worst time complexity can be O of n, right? The worst time complexity can be O of n. See, if the s2 is non-empty, then it is working in O of n time complexity, right? But the case where s1 the case where s2 is empty, right? The case where s2 is empty, so we are putting all the elements from s1 to s2. So at max the time complexity will be O of n here, right? Where n is the number of element present in s1, right? N is the number of element present in s1. Similarly, if we talk about the top operation, then again the time complexity is going to be O of n, right? The time complexity is going to be O of n. I had explained the same reason here as well, because we are using a while loop. We are putting all the elements from s1 to s2. So at max the time complexity can go up to O of n. And here if we talk about the is empty function, then here the time complexity will be O of 1. So I hope the code is clear. I hope the intuition is clear. Now let's fastly code it up on LeetCode. So now we are here on LeetCode. So firstly, what do we need? We need two stacks. So let me just create two stacks. So we are just creating stack. which will hold integer values, and we will have a stack named as S1, we will have another stack named as S2, right? And then we will have a size variable. It will be initialized to 0. So either you can just directly initialize it to 0, right, here as well, or what you can do, a better approach is to initialize the size in our constructor, right? So we have initialized the size inside our constructor. And now let's do this push function. Let's implement this. So it is going to be very easy. We just have to directly push the element into our stack number 1. So we will do s1 dot push x, right? s1 dot push x, and whenever we are pushing an element, into our queue, then the size is getting increased, right? The size is getting increased. Now whenever we have to pop out, so firstly I need to check if the stack number 2 or S2 is non-empty, right? If it is not empty, then what I have to do, I will take the element which is present at the top, which will be nothing but S2 dot top, correct? I will take the element which is present at the top, then I will do S2 dot pop. Now when I'm doing a pop operation, size is getting decreased by 1, so I will do size minus minus, and I will directly return the element, right? I will directly return the element because we have to return the element which we are popping out, right? Okay, this is the first case. Let's talk about the second case. The second case is if our S2 is empty, right? If it is empty, then what we have to do, then we need to push all the elements from S1 to S2, right? How we will do this? We will write while not of S1 dot empty, so it will be empty, while of S1 while not of S1 dot empty, we will do S2 dot push S1 dot top, correct? And then we will do S1 dot pop. So in this way, all the elements from S1 will be shifted into S2, and after doing this, we just need to do the same thing. So I can probably copy this and I can paste it here. Yeah, so I can paste it here. So here also we are doing the same thing. We are taking the element which is present at the top, we are popping it out, we are decrementing the size, and we are returning that element. Okay, so I hope this is clear to you. Now we have to get the peak element, so it is also very similar. So if not of S1, if not of S2 dot empty, right? So here we are just checking if my stack number 2, right, S2 is not empty. If it is not empty and I have to return the peak or the front element, I can just directly do return S2 dot top, right? Okay, and if this is not the case, that means my S2 is empty. If it is empty, I have to put all the elements from stack number 1 to stack number 2. How I can do this? I can do this with the help of this while loop. I'll write while not of S1 dot empty, I will do S2 dot push S1 dot top, and then we will do S1 dot pop, correct? Now after doing this, we just have to return the topmost element, so we will do return S2 dot top. Okay, and here if we talk about the empty function, it is very simple. We just have to return size equal to 0. Okay, so this is our code. We have initialized two stacks, that is S1 and S2. They both are going to store integer values. Then we have a size variable and it is initialized to 0 inside our constructor. Then we are implementing this push operation. So whenever we are getting a push operation, we are just pushing it into our stack number 1, that is S1, and we are incrementing the size. Now whenever we are getting a pop operation, then what we have to do, we have to check that if the stack number 2 or S2 is not empty, then I will take the topmost element, then I will pop it out, I will decrement the size, and I will return it, right? I will return it. Similarly, now if the stack number 2 is empty, then I will put all the elements from stack number 1, S1 to S2, right? And after doing that, I will do the same thing. I will take the topmost element, I will do the pop operation, I will decrement the size, and I will return that element. Similarly, when we have to give the peak or the front element, what we are doing, if S2 is not empty, if it is not empty, then I am returning the topmost element present in stack number 2, that is S2. If it is empty, then I am putting all the elements from stack number 1 to stack number 2, and then I am returning the topmost element from stack number 2, right? and the empty function is very simple. I'm just checking if the size is equal to 0, return true, and if the size is not equal to 0, return false. Now let me just run this. Okay, so here you can see that the two sample cases are running fine. Let me submit this. So here you can directly see that this particular solution is accepted and it beats 100% as well. We have one more approach to solve this problem, and I would like to discuss that particular approach as well, but the length of this video is already around 30 minutes, so I don't want to stretch it long. So I will make a different video for that particular approach, and I hope you will watch that video as well. And if this video was helpful to you, then make sure you like this video, you subscribe to this channel, and make sure to comment if you are facing any issues or if you have any different approach. We will meet again tomorrow with the new video, but don't forget to watch the another video of the same problem with a different approach.